It's 7 o'clock, which means it's about dinner time, and there's a few things happening in my kitchen. Well, the first thing, we're going to have teriyaki chicken, which is delicious, and that's in the oven right now. I'm going to show you what it looks like. Oh yeah, looking good. So, if you've ever seen raw chicken, you know that it doesn't look like this. Cooked chicken looks a lot different. Its color gets darker. As we can see, there's a color change. Also, there's a lot of juices in the pan. Remember, those juices and the mass of the cooked chicken, that's the products, has to equal the mass that started. Matter just can't disappear, it has to be conserved. And we know this is a chemical change. The chicken is cooked. We also know that if I want to warm up my frozen peas, well, pretty much I'm just making sure that ice goes away. Ice is going to turn to water, which is going to turn to steam. That's a phase change, so that's a physical change. That's not really cooking. And then over here, I got a similar thing. I'm reducing my sauce. So I see bubbles, but those bubbles are actually just the water that's in the sauce is being evaporated. And as it goes into the air, the sauce gets thicker or more dense because all of that liquid that used to be in there is now gas. But of course, matter is still the same, it's just in the air. So the only chemical change that's really going on is when I cook that chicken. And it changes color as it absorbs heat. Today we're going to talk about reactions that absorb heat. And a good Greek and Latin root to write down is therm. Think about thermostat, thermometer, a thermal sweater. Therm always means heat. Gotta take that out. It's timing. Cooked because, of course, heat. That's a chemical reaction. Let's write our Greek and Latin root down. When we cook, the heat goes into the chicken. It's a reactant. Raw chicken plus heat equals cooked chicken and a little bit of grease. That's called endothermic when heat goes in. And there's a few things to note about endothermic reactions. If the heat is going in, that means that the chicken is absorbing heat, which means the surroundings actually get colder. What it means is that in order for that reaction to happen, atoms need energy. There's a reverse of this too. Sometimes, instead of the atoms needing energy to combine, they really want to join and they create energy. We call that exothermic reaction. Exo means out. And that's our next vocab word. That's when energy is produced or created in a chemical reaction. There are a few things to note about this, and they're pretty much opposite. If the heat is getting created, that means the surroundings must get warmer. And the atoms, when they combine, are creating energy. So today we're going to practice this. Remember, an endothermic reaction is a reaction that needs heat to make those reactants combine. If it needs heat, it's got to take it from the surroundings so the surroundings get colder. Exothermic is the opposite. Exo means heat goes out. It creates heat as a product. If heat's going out, that means the surroundings are going to get warmer. The temperature increases. We're going to practice a lot today, and I hope you guys have been enjoying seeing how cooking is chemistry. Let's practice.